guys, we're going to talk about chemical reactions today. This is our last unit of the semester. So we're going to incorporate lots of formula writing and all the things we've learned so far into this unit. So get ready. First of all, let's talk about what a chemical reaction is. It's a chemical change in which one or more substances are destroyed and one or more new substances are created. Really what we're saying is that atoms are rearranged. Okay, so in this example here, before what we start with, our reactants are hydrogen gas, so that's our H2 gas, and oxygen gas, that's our O2 gas here. What happens is these go through a chemical change. Something happens like heat is introduced to it or electricity, different ways for this to happen. And what you get out, our products, are H2O liquid. So we started with hydrogen gas and oxygen gas, and together they ended up making liquid water. Okay, so what happened here is that these substances were destroyed, the H2 and the O2, and we ended up getting water out of it. So the atoms were just rearranged. That's a key word you'll see a lot. The atoms are rearranged. We need to talk about the conservation of mass, or conservation of, sometimes it's called conservation of matter. And really, for the most part, it means the same thing. During a chemical reaction, atoms are not created or destroyed. This is the conservation of matter or mass, okay? They cannot be created or destroyed. They exist, and you can't get rid of them, and you can't get more. So for an example here, we have hydrogen and oxygen gas. It's the same example as before, react to form water. So we have H2 and O2 react to form H2O. Now, if we look here, here's a little problem. We started with 2 hydrogens and 2 oxygens, but we end with 2 hydrogens and 1 oxygen. Well, this isn't magic, so that oxygen can't just disappear, okay? So we need to look at that equation. So again, the oxygen went missing. What we need to do, our job, is to balance our equations so that we know that the oxygen didn't really go missing. So we make sure that oxygen is really there. So according to the, according to the conservation of mass, the correct way to write this equation would be 2H2. You guys have learned how to count atoms. These red numbers here are called coefficients, and they represent the number of molecules. Later we'll talk about moles of each reactant or product. So what this is telling us is we have 2 molecules of hydrogen here, okay? But that's also the same as if we have 2 molecules of hydrogen, we have 4 hydrogens. So really we're doing this 2 times 2. So right now we have 4 hydrogens on this side. And we have 1 is our coefficient here. We don't usually write the 1. We assume it's there just like anything else. So this tells us that we have 2 oxygen atoms. On this side of the equation, if we look at this, this means that we have 2 H2O molecules. So H2O and H2O. If you look at that, that means we have a total of 4 H atoms, 2 plus 2, or 2 times 2. We do 2 times 2, and we have a total of 2 oxygen atoms. So now we have all of our hydrogen going in and coming out. We have all the same amount of oxygen going in and coming out. So we're following the conservation of matter, which is what we just have to always do. And that takes us into balancing, which is going to be a really important part of this unit. Let's talk a little bit about the different parts of an equation, a chemical equation, just so you guys are familiar with that. There are reactants. Those are the chemicals you start with before the reaction. So down here, this example, we start with silver and hydrosulfuric acid. Those are our reactants, what we start with. And then our products are the new chemicals that are formed by the reaction. So those are always where the arrow points, the right side of the equation. So our new products are silver sulfide and hydrogen gas, okay? So as you guys can see, we have the same elements. We have silver, hydrogen, and sulfur. Over here we have silver, hydrogen, and sulfur. Silver, hydrogen, and sulfur. Over on this side, we have 2 silvers. 2 times 1 is 2. We have on this side 2 silvers. 1 times 2 is 2. On the reactant side, we have 2 hydrogens. On the product side, we have 2 hydrogens. On the reactant side, we have 1 sulfur. On the product side, we have 1 sulfur. So we use this coefficient here to help us balance this out so that we would follow the conservation of matter between our reactants and our products. So important that you know which side is the reactants and which are the products. Okay, so the arrow points to the product. It's an easy way to remember it. Get this guy over here. Okay, subscripts and coefficients. You guys are very familiar with subscripts at this point. It's the little number at the bottom. A subscript shows how many atoms of an element are in a molecule. So this means that we have 2 H's and 1 O because the 1 is assumed. So 1 O. Okay, so subscripts tell us how many atoms. A coefficient shows us how many molecules there are of a particular chemical. We learned this the other day counting atoms. So this tells us we have 3 H2Os. So that's H2O, H2O, and H2O. Now, instead of writing this out all the time and saying, okay, that means we have a total of 6 H's and 3 O's, you need to just multiply. Pretend that this is in parentheses and multiply. The 3 gets distributed to the H2, so that gives us 6 H's. And the 3 gets distributed to the O, so that gives us 3 O's. Okay, so same thing either way. Now, let's look at some problems here. Right here we have CH4 plus O2 gives us CO2 and H2O. The reactant side, the carbon atom is this big guy right here. We've got our 4 little H's, and then we've got our 2 O's. Okay? If you look at the other side, what you end up with here is you have 3 of these red O's, you have 1 carbon, and you only have 2 hydrogens. This is not balanced at all. You have different numbers of the atoms on different sides. That can't happen. So our job is to balance this equation using coefficients. So we get the same number of each atom on each side of the equation. Okay? So now we're going to do some examples together after I talk to you about some rules. I would write these rules down, or at least take a picture of this. Somehow keep these in mind. Subscripts can't be added, removed, or changed. Okay, you can never mess with a subscript. You can only change coefficients to big numbers. Coefficients can only be whole numbers. Coefficients can only go in front of chemical formulas. They can't go in the middle of a formula. I'm going to show you how to avoid doing that. Some tips. Try balancing big formulas first. Save little free elements that are alone for last, like Br2 or Cl2, something like that. Leave hydrogen and oxygen for last. A lot of times they work themselves out. If you have the same polyatomic ion on both sides of the equation, it's usually okay to treat it as one unit. That's going to make sense to some of you not so much, because I'm going to show you a different way to do it, kind of. There's no particular way to balance equations. Some equations are harder to balance, and some might require some creativity to solve, and some might frustrate you to no end. But they all can be balanced, unless you've made a mistake writing your formulas, which we'll get to later. There's something called the doubling rule I'll talk to you guys about. Usually in an equation with CH and O, you try choosing a coefficient you've already tried and doubling it, but we'll get to that. So there are a few steps I recommend. Put boxes, even if they're imaginary, around each substance. You can't enter the boxes. Okay, this keeps you from trying to mess with subscripts. You're going to do an element inventory. I'll show you what that is. And then you're going to use coefficients to multiply to get the same number of atoms of each element on each side. So let's do some examples. My first example that I have for you guys is, let's do KBr plus O2 yields or produces K2O plus Br2. All right, so the first thing I'm going to do, you guys, is I'm going to put boxes around my substances so I can't enter them. Again, if you feel really comfortable, you guys learned this in 8th grade, most of you. You don't have to physically put boxes around. Some of you guys, it really helps. Okay, so now I know I cannot mess with those boxes, okay? The next thing I'm going to do is called an element inventory. The way that I do this is I write my elements down just under the arrow. So I have them in the middle. I have K, I have BR, and I have O. Those are the 3 elements I'm working with here. Now what I'm going to do is I'm going to do a count on both sides. I'm going to look at how many Ks I have on the reactant side of the equation. So I'm going to pretend there's a line right here, and I have my reactant side, I have my product side. Okay, on the reactant side, you guys can count, you've got 1 K. I have 1 Br, and I have 2 Os. On the product side, I have 2 Ks, I have 1 oxygen, and I have 2 Brs. Now, these don't match, right? We have to have the same number of each element on same number of atoms of each element on each side. So this is where our coefficients come in. This is me showing my work down here, okay? So what I'm going to do is the first thing is I'm going to say, okay, well, I have 2 Ks on this side. I need 2 Ks on this side. So what can I multiply these ones by to get 2 Ks? Well, a 2. Now, what I do is I put that 2 up here, okay? Now I need to recalculate. Don't multiply down here, multiply up here. So I'm going to recalculate. 2 times K is, I got rid of that 1, now I have 2 Ks. 2 times Br, I get rid of that 1, now I have 2 Br. So this is just me keeping track. So this is my new count. I still have 2 oxygens on this side. Okay, so now my Ks and my Brs are even, but my Os aren't. So I only have 1 O over here on the product side, and I have 2 over here on the reactant side. So I know I'm going to have to put a 2 here to try to even them out. What that does is it changes my K2 to 4 Ks. So, because I have to multiply this whole thing, I have to distribute. So 2 times 2 changes this to 4 Ks. 2 times 1 oxygen changes this to 2 oxygens. Now my oxygens are great, but now my Ks got messed up. So I have to go back, and this happens sometimes, and it's okay. So what I'm going to do is I'm going to erase. So I'd recommend using pencil when you do this, by the way. I'm going to erase, and I'm going to change this to a 4 now, because I know I need to have 4 Ks on this side. What I'm not going to do is I'm not going to go 2 times 2 or 2 times 4. I'm not multiplying down here. I'm multiplying up here. So I have 4 Ks, and I have 4 Brs. All right, now my Ks and my Os match, but my Brs don't. So what I can do is I can come over here, put a 2 here. 2 times 2 is 4. So now I can look. I have 4 Ks on the reactant side, 4 on the product side. I have 4 Brs on the reactant side, 4 on the product side. I have 2 Os on the reactant side, 2 on the product side. Now I am balanced, okay? A real equation doesn't include boxes around it, but it's okay for now. Okay, so that's where your coefficients go. All right, let's try another one. This just truly takes a lot of practice, guys. I'm going to do 3 examples with you, and then I'm going to put you on your own. Okay, this one is going to be AlBr3. I know this is kind of a longer video, but I got to go through all this with you. K2SO4 is going to produce Al2SO4 3 plus KBr. All right, there's my reaction, my equation. Now, I have to go ahead and balance it. All right, so if you don't see any coefficients already, you need to balance it. So I'm going to go ahead and I'm going to put my boxes, real or imaginary, around these substances so we don't mess with them. I know I can never go inside the box. All right, So let me do my element inventory here. All right, my elements are aluminum, bromine, potassium, sulfur, and oxygen. And I'm going to show you this two ways, kind of. First, I'm going to do it this way, where they're all split up, okay? On the the reactant side, I have 1 aluminum, I have 3 bromines, I have 2 potassiums, I have 1 sulfur, and I have 4 oxygens. On the product side, I have 2 aluminum, I have S times 3 is 3 S's, I have 4 times 3, 12 O's, I have 1 K, and 1 Br. All right, so remember I told you guys to leave your O's and your H's for last, so we're not going to worry about those right now. I'm going to just go ahead and start with aluminum because it's right here. So I know I need to get my aluminums even. So I'm going to start by putting a 2 over here because I know that I have 2 aluminums on the product side. I need 2 on the reactant side. So 2 times 1 aluminum gives me 2. Now I've got to change my bromine too, though, because I put this coefficient out here. So 2 times 3 gives me 6 bromines. All right, so I might have made a little progress. I also know that my Ks and my Brs aren't right. So I know that over here on the product side, I'm going to need to use a coefficient. I might as well go ahead and use 6 to get the right number of Brs. 6 times K gives me 6 Ks, and 6 times Br gives me 6 Brs. All right, so my Brs are now even, my aluminums are now even. I need to make my Ks even. So I'm going to come over here, and I'm going to put a 3. 3 times 2 gives me 6 Ks. 3 times S gives me 3 S's. 3 times 4 gives me 12 O's. See how nicely those last two worked out? So I've got 2 and 2, 6 and 6, 6 and 6, 3 and 3, 12 and 12. So I am balanced with my coefficients 2, 3, 1, which we don't write, but we usually say it. So 2, 3, 1, 6 are my coefficients if I was writing this down. Okay, that balances out that equation. I'm going to do another one with you guys. This is one that's a little bit harder, and we're going to learn to use what I call the doubling rule. We have C8H18 plus O2 gives us CO2 plus H2O. All right, I'm going to box them in just for the visual for you guys. Okay, now we know we can't go inside those. All right, let's do our element inventory here. Looks like I've got C's, H's, and O's. Sometimes these are super easy to balance. Sometimes it makes you use the doubling rule if you have C, H's, and O's. So I have 8 C's on this side. I have 18 H's. I have 2 O's. Easy count. Over here on this side, I have 1 C. I have 2 H's. But let's look at our O's. We have to talk about the total number of O's on this side, okay? So what we have is we have 2 right here, and we have 1 right here. So we have 3 O's on that side. Don't forget that. You need to make sure you're covering all of the atoms of that element on that side. You have to count all of them. So now we need to work on this. So let's start with our C's, okay? So we can see we need to put an 8 here. So that gives us 8 C's. Now we need to recount our O's. 8 times 2 is 16 O's right there, plus we still have 1 over here. So that gives us 17 O's now. So again, don't do 8 times 3 down here, anything weird like that, okay? We're counting at the top. All right, so those aren't going to match. Let's try our H's. If we put a 9 here, 9 times 2 is 18, but we've got to recount our O's again. So 8 times 2 is 16 O's. 9 times 1 is 9. So we get 25 O's. Now, when we have an odd and an even for the O's, this pretty much is telling you you're going to have to use the doubling rule, okay? Otherwise, you're never going to get this balance. So what I mean by the doubling rule is any coefficient that I've already put there, I'm going to get rid of it. So I'm just going to cross it out. In this case, you would erase it, but just so you know what was there. This was 8, so I'm going to try 16. This was 9, so I'm going to try 18. Then I'm going to do a recount, okay? I have 16 C's now. I have 18 times 2 is 36 H's. Now let's count our O's. 16 times 2 is 32. 18 times 1 is 18. So that gives me 50 O's. And that's okay. It can be a big number. Don't let that freak you out. All right, so over on the other side now. I only have 8 C's. I need 16, so I know I can double that. There's my 2. So that gives me 16 C's. Got to change my H's too. 2 times 18 is 36. Great. Now my H's and my C's match each other on both sides. So what do I have to multiply this 2 on the oxygen by to get to 50? I'm going to have a 25 there. And again, sometimes you will have a big number and it's okay. And that gives me 50 and now we're balanced. So that's the doubling rule. So you guys should have learned a few things here. And now you're just going to go on ahead and try your practice. And again, it does take a lot of practice. So just keep trying and let me know if you need any help. Thanks.